Hello, and welcome to episode 12. This is 12 weeks of doing this with a vacation in the middle of TGI Kubernetes. This is my mostly weekly live stream where I play around with Kubernetes and everybody watches me fail. For those who don't know, my name is Joe Beda. I am the CTO of this startup called Heptio. What we are doing is helping to bring Kubernetes to a wider audience, both more developers, but also to the enterprise. So this is and also for those who don't know, I'm one of the folks who got the Kubernetes project started when I was at Google, along with a couple of other people, and so that was about 3 years ago now that we went public with it, and it's been a pretty exciting ride so far. So thanks for coming and hanging out with me. And I see that Roland here is already saying hi from Austria. Let me know in the chat if you can hear me, if everything sounds fine. Every time I do this, I end up mucking around with my setup a little bit. This time I'm starting to play around with putting a little bit of sound panel type of stuff around so that I can, hopefully improve the sound a little bit. Okay, we have Bashara from Pennsylvania. And oh, great. All right. I'm glad that things are sounding good. It's one of these things where I think anybody who does this stuff, you end up after every episode, I'm like, let's go on Amazon and buy some more stuff. So today, Andres from Hungary, nice to see you. And then Tim, you're in Chicago. For those who don't know, I grew up outside Chicago. I grew up in Glen Ellen, the west suburbs of Chicago. I realize I say I'm from Chicago, but really, suburbs are not Chicago, right? So I know that well. My family's still all back there. All right, so the plan today is that we're going to start exploring this serverless framework called Kubeless. That is, it's run by Sebastian Gowitzin. I'm butchering Sebastian's name. He goes by Seb. He started it when he was running his own little company. And then those guys ended up joining forces with Bitnami. And Jose from New Zealand, nice to see you. So those guys ended up joining Bitnami, and they're continuing to invest in Kubeless. And so it looks really interesting. And so I have a sort of high level understanding of what it does and how it does its stuff. And I've definitely seen demos and played around and looked at other people play around with it, but I've never actually had a chance to sit down and install it on a cluster and really start playing with it myself. Hello, Federico from Sweden. Yeah, good to see you. I know you guys are a little bit done for the day probably over there. So yeah. So that's my plan today, is to install Kubeless, see how far we can get in about an hour, and play around with it. We're definitely not going to be able to explore everything there is to offer. Just looking at it, there's a lot of depth there, but hopefully we can get that stuff up and running. And Hans from Sweden, nice to meet you. Scottsdale. So from all over, that's awesome. Saudi and Boston, awesome. I love it. And this is also my afternoon now, so I can officially have a beer. And so here we go. And Shoma from India, I'm sure I'm butchering your name also. Kubernetes Up and Running. So that's one of the things. So I like to start this out by doing a few announcements and talking about some stuff, like sort of what's been going on the last week. And so let's just jump into that and see where we go. So the first thing I wanted to do is I wanted to give a pitch for this thing called Kubernetes Community Office Hours. So this is something that George, who does community stuff here at Heptio, so he does a lot of stuff to help out the Kubernetes community. This is something that he's getting up and running. And I think some of it was inspired from me doing the TGIK. It's kind of fun to go live and actually interact and talk to people. Whereas I have a topic and you watch me flail around trying to learn stuff and figure it out. This is more along the lines of a sort of question and answer session where we get a bunch of folks together. I haven't actually been on it yet, so I want to go on there at one point. But get a bunch of folks together who are sort of experts in Kubernetes, and then have a little bit of live Q&A and have people be able to answer questions. And so you'll get a lot of the developers and the folks who are heavily involved in the development of Kubernetes getting involved there. So all the URLs that I have here, I'm going to put in the show notes afterwards so that you guys can go ahead and get this stuff. So we have Peter from Sweden, and we have I'm sure I'm screwing it up, from Argentina, Miguel from Mexico. Great. That's awesome. So tune in that it's the third Wednesday of every month, and George does both a European time and a sort of Western US time, and he has, like, let's see, so the European time for me ends up being 6 a.m., but George is in Florida, so it's not quite as bad for him. And then 1 p.m., so about this time. So that is the third Wednesday of every month. So that's pretty exciting. So definitely check that out. And if you're part of the Kubernetes community and you want to get involved and help answer questions, that's a good thing to be able to do there also. So both sides of it. So that's exciting. And then so some folks on the chat were talking about my book. So I actually have my own copy here. I'll make the screen bigger so that you all can see it. So this is a book that I wrote with Kelsey Hightower and Brendan Burns, called Kubernetes Up and Running. I just want folks to be aware of it. It's really exciting. I'm just really excited to actually see it in paper. It's one of those things where, you work on this stuff for a long time and you finally actually see it in the flesh. And so far, folks seem to have liked it. Well, it said that he put some erratas up on the website. That's on my list of to-dos. Maybe I'll get to it this weekend, where I want to start going and responding to those errata. I mean, there's always a few things here and there as you're missing this stuff. And this book has been through a ton of edits. I think what happened is, it's somebody called it the Duke Nukem of books, or at least technical books. Yeah, so this one's my first book. This is the first book that I've written that's been sort of long form like this. And you know how it is. You don't write technical books because you're going to get rich, right? You write them because you have something to say and you really want to help folks out. And that's kind of where we're at with this. But Kelsey started the project with O'Reilly, I don't know, forever ago. And a lot of stuff was changing. Kelsey's a very busy guy. And so at some point he asked Brendan and me to help him finish it up. And so it was a group effort for sure. We sort of split it up chapter by chapter, worked on it, and then, spent a lot of time reviewing stuff, making sure that it all read well and that we weren't totally repeating the same thing across chapters. Because, but I'm really happy with how it turned out. I think it's 200 pages, with the index and everything. So it's not like the biggest, fattest book out there, but we tried to make sure that we really cover all the core concepts of Kubernetes in as succinct and readable a way as possible. So hopefully y'all will take a look at that and get a lot out of it. The next thing I wanted to talk about, and if there's stuff that you guys have questions about as you're reading the book, that's something that we can cover in the TGIK. So if you're like, hey, could we delve into this particular part of the book a little bit deeper, that's something that we can definitely go into. And I may say, that was Brendan's chapter, that's his to dig into, but I can cover most of it for sure. And let's see. So the next thing though is we here at Heptio, we announced this new thing. Oh, BK from Boston, nice to see you. Called Heptio Labs. And so what this is that as we've been hiring folks up, as we've been building our own tools that we need, these aren't sort of like big investments for the company moving forward. It's not something that is going to make us a ton of money. And we just wanted to have a vehicle to go ahead and get that stuff out there. And as we build up our efforts in open source, we want to be a little bit clear of what is stuff that we're really investing in. It's people's full-time job. It's stuff that we're really looking to sort of support over time. Versus what is some stuff here's some cool stuff, you might want to check it out. And so the Heptio Labs is sort of the cool stuff that you might want to check out. So we got this really cool logo done for that to give you an idea that's sort of in development, sort of not super official type of stuff. And there's a set of projects here that open source is in Heptio's DNS. I think you meant DNA, Suresh, but it's also in the DNS also. So there's a bunch of fun tools here that I think you can take a look at, and it's everything from Chuck did this starting to think about sort of how do we actually manage a bunch of kube config files, and providing a little bit of a framework there, to, oh, this opened a new tab for me. To like one of the first pieces of code I wrote when we were doing stuff is I wanted us to be able to validate the DCO license stuff on our open source project. So I wrote a little GitHub integration thing called a sign off checker. Chuck did this thing for just throwing some stuff up to S3 that you can use with Sonoboy if you want. And then I think one of the really interesting, so the couple interesting things, this is probably going to be a little bit more interesting, is Tim did this thing called Event Router, which is essentially sucks events out of a Kubernetes clusters and then throws them someplace else, right? Because if you've used the event system in Kubernetes, you'll realize that it's garbage collected fairly aggressively because those things are stored in etcd, and etcd is kind of at a premium. This essentially is a way to sort of grab those things and actually save them off someplace like maybe an Elk cluster or whatever. Somebody are saying that Barash says live in 2 minutes since the last 10 minutes. You might want to try and give it a reload. Can somebody sort of chat to him and say give it a reload? Because I think I'm projecting you all seeing me. So Roland's like, I'll ask this again, but we show how to run LBs in a non-cloud environment, bare metal, and a TGIK. I would love to do it. I think it's just the setup around that ends up being a little bit tricky. I'll think about that. One of the things that we have here that I'd love to show off at some point is we have a stack of Intel NUCs, which are their sort of like small form factor types of things that that we use as sort of a little bit of a lab for bare metal type of stuff. And so if I can figure out the right way to sort of, use those and broadcast with those, that might be a good way to actually start showing some of that stuff. But the reality is that as you start doing this stuff on bare metal, things get, there's so many more degrees of freedom. And so it's a lot more of, it depends type of things that are coming on there. So, all right. Okay, so the Heptio lab, so there's this event router, so that's really cool, and I think that's sort of definitely scratched the itch for a few folks. And then there's this other project here that Matt Moyer did, which is a Kubernetes AWS authenticator, and this is a way that you can use AWS credentials to actually authenticate yourself to the Kubernetes cluster. And so it's still very early on, but this is really, really interesting stuff there. So that's Heptio Labs. There's the GitHub org. And then I wrote another book. This one's a short little ebook. It's and it's really aimed at a very different audience. A lot of this stuff is stuff that I've been talking about for a while, about sort of what does it mean to be cloud native? How do you deploy, apply this to your organization? This is something that we did with the Linux Journal, and it's more aimed at decision makers inside of companies that are looking at using things like Kubernetes to change the way that they deliver and manage software. And so we did this with the Linux Journal. You can go ahead. This is on blog.heptio.com, and I'll put this in the show notes also. So if you want to download this and get an idea of what's going on there, that would be great also. Let's see. So a couple more things that I wanted to actually get to. We are hiring here at Heptio. I don't want to make this be too sort of pitchy, but we're definitely looking for folks in the, especially in the solutions engineer space. And this is everything from, helping customers be successful with Kubernetes with sort of tools as they are, and make that be a repeatable thing, to how can we actually build new tools and new systems that are going to solve specific customer problems. So there's actually a sort of a split on making what is work and then actually filling the gaps and writing new code and new systems there. We are hiring folks mostly across the US. Just because it's so difficult to actually manage, across time zones and across countries in terms of being able to employ people. So right now we're focused in the U.S., but at some point we're going to be looking wider than that. So if that applies to you, or if you know folks, definitely give that a shot. And we're hiring for a bunch of other roles too, but this is the one that I definitely wanted to call attention to. And then there was one other project that was demoed at the community meeting yesterday that I wanted to actually call attention to, because I just think it's really cool, and it's sort of like, it reminds me of stuff that I did earlier in my career. And this project called Vert. Now there's some folks at Red Hat that are driving this. And you can, if you want to see a demo of it, you can go to the community meeting recording. George does the recordings for those also. And so those are 10 a.m. Pacific every Thursday. And so if you want to get more involved in the Kubernetes community, that's a great place to actually start figuring out who's doing what and how things are coming together. But anyway, so KubeVert is really interesting because this is running VMs on top of Kubernetes. And so what happens is that when you want to run a VM with this system, you create a new resource. It's a CRD, a custom resource definition. So you create a new resource, and then a system, watches that, and then behind the scenes goes ahead and starts up a pod, and inside that pod is running the virtual machine using KVM and QEMU. And so your API to your VM system ends up being integrated with Kubernetes. Now, there's still a bunch of stuff that I don't quite understand how it hooks up with networking and storage. I think it might be a sort of different system on how that stuff works. Those problems get really tricky. But that's really cool because now you can actually start using Kubernetes as a more traditional VM-based cloud system. Still early on, but really, really interesting work being done there. And the reason why this reminds me of work that I did early in my career is that I started the Google Compute Engines system product when I was at Google before Kubernetes. And that was essentially running virtual machines inside a Borg, right? So it's very similar to that, and there you see a lot of echoes, in terms of how these folks approach solving problems and how we had to solve those problems inside of Google. What I really want to do is try and get this running on top of GCE, because GCE now supports nested virtualization. So we could have a VM running in a container, running in a VM that's running in a container. I think that'd be pretty cool. But I haven't had time to play with that yet. Maybe that'd be a good TGIK project. So that's a little bit of a whirlwind, and we're already 15 minutes in. This is how I go over. But hopefully that was all interesting, and I'll definitely put links to all that stuff. So the main event here for this TGIK is we're going to actually be playing with Kubeless. And so you can get to kubeless.io, and I was looking at the install page there. I have not played with this yet. And so I'm coming at this relatively new, which means that I'll probably screw some stuff up, and I was going to try and find some time and sort of pre-flight this, but I ran out of time, so we're going to be doing it live. For those who are not familiar with serverless is, and I'll do a little bit of a primer from my point of view here, serverless can mean a lot of things to a lot of people, but in this context, what it means is that it's the sort of compute runtime parts of what you might think of as a platform as a service. You give this thing a snippet of code, and it manages figuring out how to package it up, where to run it, and then how to scale it. And so you have some code, and then when an event comes in, when an HTTP request comes in on a timer, whenever those things happen, your code runs, right? And so you don't have to think about container images. You don't have to think about, you think hard about the versions of the software that's underlying your stuff. You don't have to think about, well, how many replicas do I need? And when you're running this stuff at scale, it ends up being, end up being a lot cheaper because you don't have a bunch of sort of empty containers actually sitting around waiting for something to happen. And so it ends up being, the whole definition of Kubernetes is that it's actually very dynamic. That's sort of one of the reasons that it works. This is another level of dynamicism here. Now, there's some trade-offs that come along with this. The managing these functions and actually testing and integrating them can be trickier, and there's frameworks and there's tools to really help you do that. And depending on which system you're using and how you set up your constraints, you may find that you can't have requests that last too long, or if you have to keep a lot of stuff in RAM, that actually ends up being difficult to manage in that. So these things only work in the context of having other systems that you can depend upon for doing things like storing state and caching and eventing and that type of stuff. And so it's kind of fascinating, right? So across these two, I didn't realize this now until we were talking about it, is I have this thing where we're talking about running VMs on Kubernetes, which is very much sort of this, more traditional compatible model with how the old world thinks. And then we have sort of Kubeless, which is even more sort of dynamic than Kubernetes itself. Soima says, how does this differ? And I'm sorry about your name. That's all me. How does this differ from the Kubernetes cron job? So the Kubernetes cron job is really it gives you a lot more degrees of freedom. It's like start this container at this time type of thing. Whereas this is start this code at this time. And it's a slight difference because containers are more than just code. It's like it's the entire sort of environment that you want that thing to run in. And a lot of times doing something like a serverless system is actually good enough for your use case. There are going to be times when you're going to want to have more control of the entire stack, when you're going to want to have more control of where and how things run, and that's when you might want to use something like the cron job. It's a difficult thing to actually reason about. But another thing to think about it is that when you create a container image, you have this artifact that you're actually dealing with. When you install a function into something like Kubeless, that function it feels a lot more mutable. It feels like it's a lot more that you can sort of just go in and tweak it type of thing. And so the container processes lend itself to a little bit more deliberatism about how you actually go ahead and build this stuff. So BK says, isn't serverless the new cloud EJB meme? You know, there's... Every time we do something new like this, you can always look back and say, hey, this is just like the thing that we did before. I think there's a lot of people that, you know, say inside of Google, they'll look at Lambda and they'll say, hey, this is just like App Engine, right? So AWS Lambda is you know, one of the first things that really kicked off all this excitement around serverless, you know, whatever serverless is. But so folks, you know, there's definitely similarities between a traditional platform as a service and something like serverless. And I think you can also look at things like EJB in that same context. I think one of the things that for me, you know, makes a difference between this and some of those other things is that serverless is really an infrastructure piece. It's not the entire platform. You need to use serverless with a queuing system, with a database, with some sort of ingress type of thing for actually getting traffic in, right? Usually with a platform, all those things come as one package. With serverless and with things like Kubeless, there's much more room to sort of mix and match the components that actually sit around. So this is really, think about like you have a traditional platform as a service, and you're breaking out just the running of stuff from configuring all the other things around it. And that's really where serverless is. So I think it's okay to say that you know serverless might be one of the building blocks that you use to build a sort of custom platform as a service or something that feels like a platform as a service. But it really is more of an infrastructure level thing in my mind. You know, but you'll ask 10 different people how this stuff works and how it compares, and you'll get 10 different answers. So that's just my take on this stuff. All right, so let's go ahead and get in there. So now, there is an install thing here on the kubeless.io, and I'm looking at this, and this looks good. One of the things, though, is that I was digging around on the GitHub page, and there's install instructions on the GitHub page also. And there's some differences between these. Like this one talks about third-party resources, which are the old and busted way to do sort of custom resources. Whereas the GitHub page talks about custom resource definitions, which is the new hotness in terms of custom things. So that makes me think that the GitHub page is probably more up to date. So those are the instructions that I'm going to go with. The other thing that was here is that they have instructions for installing into clusters with RBAC turned on. And the cluster that I'm going to be using is based on the Heptio Quick Start on AWS. And so it has RBAC up and running. So we're going to go ahead and do that. And then the other thing is it says, okay, download the Kubeless CLI from the release page, and OS X users can use Brew. So let's go ahead and do that. Let's do, so I was, so I have a cluster up here. And you've seen me do this a ton of times, and if you have questions about it, let me know. But you can go back and look at some of the previous episodes. And with this cluster, I have 4 nodes. It's running 1.7, and this is running in Amazon. It has RBAC enabled, but I also have the Nginx ingress installed on this also, because I thought we might need that, or that might be something interesting to play with here. And I did that using the setup that I talked about last week. So we have a relatively sort of bare cluster, and then I'm going to use Brew on my search Kubeless to get the client here. So let's see what we have. Oh, it said, did it lie to me? Let's see. So for those who don't know, Brew is a package manager for the Mac, and it makes it easy to install. Oh, that didn't work, man. You can also install using Brew. How do I do this? All right, well, I guess Brew doesn't work. So that's, I'm gonna take a note. I'm gonna give Seb and folks some feedback here, but the Kubeless via Brew didn't seem to work, but we can download this stuff directly. And so probably from the release page here. Okay, so V0.23 is the latest release. Now I'm glad I'm doing it from the GitHub page because the website, yeah, I might have to install a brew tap. I'm not gonna figure out how to do that. We'll just do it the easy way. And here is Kubeless Darwin AMD 64. That sounds about right. And let's see. Oh man, Kubeless Darwin. Okay, I'm just like looking like, oh my goodness, did I actually spew anything that matters? And they're like, no, that's all stuff that was like early drafts of Kubernetes up and running stuff. So I'm copying that. We'll unzip that. Okay, so let's see, what are folks saying in the chat? Brew update. I did do a brew update before I did this because I know brew update sometimes takes a while. Oh, okay, so Andrea says brew install Kubeless tap Kubeless. Okay, brew install Kubeless tap Kubeless. Updating brew. I just updated brew, so you shouldn't take too long. Let's see what happens here. No changes. Okay, there we go. Oh, magic. Okay, say 2023. Is that the latest? Yeah, look at that. Fancy. Very nicely done. All right. Okay, very off topic. JP's asking, do we figure out why the kubelet get nodes? Well, let's talk about that later. I think it's just we changed some of the annotations and things got, but now you can see get nodes. We actually have this roles here, and we actually see the master gets notified now. So I think that got fixed in kubectl 1.8 because I'm running the 1.81 version of kubectl against a 1.76 cluster because we did the upgrade stuff last time. Okay, so now we have the kubeless binary up and running, so that's great. Oh, look, and it actually has like here, you do this to actually install kubeless into your cluster, but we want to do the RBAC thing. So let's actually follow the instructions here. So it says, okay, I want to do release equals 2.3. So let's do that. And then I want to do this. All right, actually, we're going to, let's see what this thing actually looks like. Oh. Ooh. You are being redirected. I have to give curl the -L. So I'm going to actually download that first so that we can take a look at it. So actually, aren't you getting validation errors when kubectl and Kate's versions are not matching? Usually it shouldn't cause a problem. I think that there's one issue that I saw fly by that you got these sort of benign errors around protobufs. The way that we work things with Kubernetes is that we talk about API versions, and kubectl is actually written to work against different API versions, and those API versions are stable across Kubernetes clusters. And so things should work with relatively decent amounts of version skew between clients and servers. This is one of those things that decision that we made early on in Kubernetes is that we wanted the APIs to be stable. And one of our goals at this point is to, and it's going to be a ton of work, so volunteers welcome, is that right now the kubectl code is in the big repo with the rest of Kubernetes. And we're talking about what is it going to take to actually remove that from the rest of Kubernetes and maybe put kubectl in its own release cycle. So because, there's a lot of ideas on how people want to improve kube control, and there's no reason why we can't get new features out in the client faster than the rest of the cluster software, right? Okay, so we got that here, and so we have this. So I always like to, it's good idea. Oh, look at Visual Studio Code has a new icon. So it's always a good idea before you go ahead and install this stuff. You want to understand what's going on. And so I'm going to go ahead and look at this. And Daniel's saying, yeah, I want to create the namespace before we go. I saw that, right? So sometimes what you'll have is these install scripts will create the namespace for you. Other times they'll expect you to go ahead and create the namespace. And I think that's actually a good thing. Sometimes, if you have an administrator, they'll actually create the namespace for you. And you may not have permission to create a namespace, but then within that namespace, you can go ahead and do what you want to do. But some of the stuff that we have here with RBAC, things like installing cluster roles, that's usually going to be a super user type of thing. Yeah, so the protobuf thing got fixed, and that was benign, so that's not a big deal. Yeah, and the roles column is in kube control. Yeah. Okay, so this is doing some RBAC stuff, and the kubeless controller deployer is a cluster role, and it's essentially able to do everything with services deployment functions, which is a config maps, pods, and replica sets across all API groups. So this is a little bit wacky because you might have different API groups installed with different services. So I think this is probably some feedback that I'll give them, is that RBAC shouldn't use star for the API group. And honestly, I'm kind of surprised that RBAC allows you to do that. I should talk to the SIG-auth folks and see what they were thinking there. And then we're binding that to, so let's see, subject to a service account, the Kubeless service account. And then at some point, we'll probably create this Kubeless service account. Here's the service for Kubelet, the controller account, okay. And then we have a stateful set called broker. The stateful set is going to have some volume claims, okay. Hey, Elric. So the volume claim, so what this means here is that this isn't going to work on a cluster that doesn't have some level of persistent volume support. So that's something that you're going to want to actually look at pretty closely. And this is probably because it's running Kafka. So this is for the Kafka, and it uses this for essentially queuing. So that's good to know. Wow, and then we're going to run, so we got that, and we got another stateful set for Zookeeper, because Kafka uses Zookeeper under the covers. What this tells me is that, and it says allow anonymous login, which is fine for something like this, but this tells me that if I was going to install this in a sort of production environment, I would probably want to, be a little bit more careful about making sure that I had the right replication and everything going on here, because I believe there's no... This is one replica here for Kafka, and then there's one replica here for, let's see, and then one replica for the Zookeeper. And things like allow anonymous logging kind of scare me for production usages. And then we're deploying the Kubeless controller, and I assume this is the thing that watches the CRDs and then goes ahead and creates pods and manages those. Here's the service account that we're talking about that we did the binding for. And then here's the CRD. We have a CRD. It's called functions.k8s.io. That is interesting. This probably shouldn't be using the k8s.io because it's not an official Kubernetes project. They should probably be using something like kubeless.io. And this is one of those things where we don't have a lot of clarity on for folks is anything that's kubernetes.com or k8s.io, we should have a central registry that's actually sort of, blessed by sort of the Kubernetes group. What we find is that a lot of people just sort of make stuff up as they go along, and so it can create some confusion there. And so this is creating a new CRD that is a namespaced resource, which means that these exist within the context of a namespace. And it's called a function, and it's functions and functions. So it's just all the different names for that. And And then let's see, we have a service for Zookeeper. Did we not have that before? Zookeeper didn't have a service, I guess. It's a little out of order. Okay, yeah, so we have a service then for Zookeeper. Oh, we have two. Fascinating. Okay. Okay, so the zoo service looks like it is for a bunch of zookeepers to talk to each other. And so that's port 9092 and 3888. And then the zookeeper service is for clients to be able to talk to zookeepers. So that's great. That's a great pattern. That's interesting because there's two services pointing at the same servers, but those services are actually for different users. One of them is for those things to talk to each other. And then the other one is for clients to be able to talk to those things. And that's a great example of the flexibility of Kubernetes where you can have multiple services pointing at the same set of pods for different purposes. And right now, I believe there's just one server going on, right? But I guess that peer stuff still needs to be plumbed through. Fascinating. Okay, cool. All right, so that seems pretty simple. Let's go ahead and actually install that. So we have to do create Kubeless, right? And because we did that, and then we have to go ahead and we have to do this. Oh, is this? Yes, and this is all going to happen in the Kube namespace. So we do. I'm going to do it at apply. All right, that was easy enough. So that at least created all these things. So the server accepted it. Let's go ahead and one of the things that I'm playing around with TGIK this time is using the Kubernetes UI to be able to see what's going on. So if you all don't know, when you run the UI, what you can do here is you can do you run this thing kube control proxy, and that essentially does an HTTP proxy, mostly just used for the UI. And then you, whatever that points you to, for me it was localhost 8001. Then you go /UI. I think you do that. And sometimes this will actually give you blank. And there was a bug that I found. If you do, you have to put a slash on it to make it work. Otherwise, it gets confused. And I think, Elric, this might have been what you were hitting the other day. I'm not sure, but I did a little bit of Googling and I found a thing that said you have to put a slash on there. So that was pretty confusing for me. So let's go ahead and look at the Kubeless thing. Okay, so we're seeing here that the persistent volume claim is not bound for Kafka. And what is going on here? Source default scheduler. So the events. So we know that it's not bound. Let's see if we can figure out what's going on there. Pods, replica set, stateful sets. So I hit my first snag here. What could be the optimal use cases for having more than one service which are using the same pod? So you could have something like a canary type of thing that only points to a subset and service, and then you could have another service that points to your canaries and your things, across everything. If you're doing blue-green, you could have one service called blue, one service called green, and one called prod, and you actually change prod to actually be one or the other, but then you can explicitly address those things. And so those are a couple scenarios where you might want to have multiple services that are all talking to the same set of pods. So let's try and do... So let's see what's going on here. So this is pending. Okay, so it's still working at it. I think it just may be that we're waiting for Amazon to catch up. And we're going to do describe PVC failed binding. All right, so that's not good. Uday says, I followed. Were you doing it with AWS, Uday? How did you start your cluster? So let's see if we can figure out what's going on there. It could be that there's something wrong with my cluster because I just did start this thing up, and that would be bad. Let's do You can see me do some live debugging here. Let's look at the controller manager. Okay, get okay, so we're not seeing any errors there. You seen anything about volumes? No, that's not. I thought this stuff happened. That's not a useful log line. I thought this stuff happened with the controller manager. Maybe it's happening in the API server. So we're not actually creating volumes. What the heck is going on? Storage class. Oh yeah, okay, so maybe it's asking for a storage class that we don't have. That could be actually a good point. Let's see, I'm gonna have to sort of make some of this stuff up. Let's go through and let's look here. Claim templates, access storage 1 gigabyte. Do you have to define a storage class? Define storage. Let's see what we find. It used to be that there was a default storage class, but our provisioning, dynamic binding, reclaiming, retaining, recycling, deleting, expanding claims, types, blah, 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 capacity, access modes. I think it's probably the storage class. Let's see if we can figure out what's going on there, though. But I want to see that in an error someplace. I thought it was... Just a second. Kube system get pods. Let's look at the API server and see what it says. Okay, so we're getting some... This is just random people on the internet trying to break into my cluster. Storage class, yeah. Okay, so Andy, what are you saying? Blob, add-ons. So yeah, so Andy, I think what we need is we should probably install a default storage class for a quick start. So we don't have anything, and this used to work. Did this change where there's no longer a default one? So let's go ahead and let's make this work just to get past it. Does this look right? So this is GP2, is default class. Yeah, if you don't do this, then like everything gets confused. This, I think, yeah, let's just go ahead and get that. Curl -lo. K apply -s storage class. All right, so we're making this work. So that's good stuff there. So now what are the? This is actually one of the fascinating things here. If this works, yeah, namespaces. Yeah, so this is cluster scope. Storage classes are cluster scope. So the idea that we're going to take a little bit of a detour into persistent volumes is that persistent volumes are a thing that is generally allocating those is going to be an administrator level thing. But a volume claim is essentially a user saying, hey, I need a volume to do my thing, right? And so what happens is volume claims get assigned to volumes. And that can be done automatically, or you could, conceivably have an administrator say, well, let me allocate these things for you because like I have to go click around in some console on my SAN someplace or something like that. And you can have your set of volumes pre-allocated, or if you're in a cloud, you can have that actually be auto-provisioned. So that means as soon as you have a volume claim, there's a system that says, oh, here's a claim. I don't have a volume to match it to. Let me go ahead and create a volume to be able to do that. And so as part of this whole process, you have this idea called a storage class, which is when you go ahead and you want to talk about, oh, I need a volume. Well, it's what kind of volume do you want? Because they're not all the same. And what kind of volume you want ends up being very specific to the storage system that you're using. And so it's a way to actually go ahead and separate all of that. Okay, so it's still saying it's not bound. Get PVs. And Kubeless. Okay, so there's a PR on our quick start, so we're going to fix that. So this is still pending. Scribe. Let's see if, okay. So this thing is, it's still continuing to try. It's probably in a little bit of a back off loop here. Oh, it said it failed again. Shoot. Okay, so our quick start repo. So Andy, I don't know if that worked for me, man. All right, so we have this here, default, it's got the right provisioner, AWS EBS. Let's go ahead and look at our AWS console here. And we have volumes, but we only have volumes for instances. These are not the volumes we are looking for. So something is confused. Yeah, I think I'm going to create that stateful set. Let's just do get stateful set. It should work, but it doesn't seem to be. Oh, it's SS is not the. It's not the. All right, so it created that. All right, now let's go back. So I just deleted and recreated it. It's apparently the Kubernetes equivalent of, okay, so we got this. We're still seeing the same thing going on here. Created by that, created by, so created claim. So we created the claim, and claims don't show up in the, in this thing here, so, but we have persistent. There's no persistent volumes in the cluster. If it helps, you can skip it. Yeah, I think what we can do. Is there Wanjo, do you know if the, so yeah, Suresh, I don't know if pending status means that the schedule is not able to sign, or it's, I don't know if it's actually creating it. So I don't think that, oh, here we are. Okay, so now it's actually happening. Okay, so here is the 8 GB, which is probably the minimum size that we can do, that can get created. So Amazon's taking its sweet time, and eventually this thing will actually get bound. So I think we're making progress here. Maybe. It's a little bit slower than I'd like. This is what happens when I don't pre-flight this. I would have actually figured it out, but I don't know. Maybe it's useful for folks to be able to actually see how this stuff works. So I don't see any logging on this. All right, let's give it a few more seconds here, and then I'm gonna try doing the no PVC thing, and we'll actually move on with our lives. Yeah, so Keith, well, it's one of these things where it's like the first time, you do one of these things in a while, you sort of hit all these things, and then you learn, and you're like, that should work, and it's not working. Oh, here no persistent volume claims available for this claim, and no storage class is set. Okay, so it's still not finding the storage class. And so what that tells me is that when we did the storage class thing, we had this, this is default storage class true. Maybe that is a 1.8 thing. Maybe they changed this in 1.8. So what we're going to do here is this thing is called GP, and let's go through and let's see. Rename default storage class. Let's look at the history on this to actually see. No, that's not it. Okay, it's got renamed from default to standard to GP2 or whatever, right, for different things. Let's search for this. See what we see. So, oh, look, we got a user guide on this. Annotations. That should work. Why the heck isn't this working? Okay, so now let's look at the, I want to make this work. This is one of those things where I want to like beat on it until it works. Maybe update stateful set volume claim template to reference storage list. Yeah, that's what I'm thinking, Steve-O, is we have the volume claim template. How do you use it? Resources, namespace. I want to, how do I specify? All right, let's look at the PVC documentation. So, in the past, the annotation volume beta Kubernetes storage class was used instead of the is still working. However, we don't want to do that. This is storage class name. Where does that actually sit in the YAML? Oh, it's called storage class is default, not beta. So this is one of the problems with annotations. So let's do that, and let's try and update the storage class. Do that. Yeah, no, I'm going to try that. If this doesn't work, Steve-O, then I'm going to try and actually explicitly put the storage class in the stateful set definition. Let's actually give this. Gah. Let's look at the storage classes. We got that. GP2, oh, YAML. This thing actually is the annotation. Okay, so we got storage class Kubernetes IO is default class equals true. Oh, this is fascinating. Is it true or true? Stupid YAML. I wonder if you probably have to quote the true, but all right. Now let's go ahead and we're just going to actually, this thing is called GP2, the storage class in this thing, I believe it's probably something like, let's just do storage class GP2. And that is in Kafka. And does Zookeeper have a, I don't think Zookeeper uses PVCs because otherwise we'd be seeing errors there. Yeah. Let's do an apply on that. error validating blah, blah, blah. Unknown field storage class. So, okay, so this is what I was worried about. So persistent volume claim spec. This might be a 1.8 thing. What if let's try and do 1.7 here. Oh. It doesn't take me to the same thing in that. Oh, this is lame. Okay. Okay, so it's V. I'm trying to actually find the 1.7 doc, so that's annoying. Okay. Let's see. Let's see. Magically, does that work? Oh, yeah, look at that. That's the 1.7 docs. Okay. So class. Oh, it's storage class name. That's lame. Okay. Yeah, you're way ahead of me, Steve-O. Okay, so you can't update that. So I have to cube control K, Kubeless, delete, stateful, set, Kafka. All right. Now, is it gonna freaking work? All right, so we're still seeing. All right, the delete didn't actually, okay, we didn't wait long enough for the delete because it didn't do the GC thing and actually delete everything downstream from it. So we reapplied it too fast. So this thing should eventually, this PVC should actually end up being deleted. I think, yeah, I did get storage class name again. Why is this? All right, well, let's do. Right, let's give it a try. Oh, finally. All right, so yeah, so I think what happened here is that when I deleted it, it didn't delete the PVC, and so that thing, it only checked for the storage class the first time, and all that mucking that we had done, probably we didn't actually go ahead and re-kick it because we needed to have the storage class there beforehand. It probably tries to apply the storage class, the default storage class at admission, and so that means that it doesn't eventually get hooked up. Yeah, so I think that's right, that the delete stateful set Kafka did not actually delete the PVC. So that was an adventure. And now this thing is, it's probably still figuring it. Oh, look at that. It's up and running. Wow, that was actually fast once it got moving. And now I look at persistent volumes, and then here we have the PVC, the persistent volume here. That took way too long. Yay! Okay. Well, okay, so for the Kubeless folks that may be looking at this, that was all you. I mean, that was all me, not you, right? That was my cluster not being totally ready to go. But we learned a little bit around that stuff. I think it would be useful in the install instructions maybe to actually call out that you need persistent volume stuff. Because not all cluster have that. And I think it was somebody in the chat, and I think it might have been Steve-O was saying that there's an alternate YAML that doesn't have the stateful set. The PVC stuff. And so this is a whole nother problem of how do you describe these things. Like when projects like this have to actually ship out 3 different YAMLs, it's kind of a pain. But now we're actually ready to actually start doing something. So let's see. So we can do kube control functions. And it says, oh, no resources found. That's what we expected. And then let's do a toy thing here. This sounds great. So I'm going to create that. I'm going to call it test.python. I want to actually sort of do some stuff now. Okay, so I'm going to create a new file. I'm going to put this in here. It's essentially going to do a hello world-ish type of thing. Test.py. So that's good. Oh, and then no, I'm not going to install Pylint right now. I don't do that much Python. And then I should be able to just run this stuff. Let's read what we got going on here. Yeah, credits to, oh, it's John Joe, Juan Yo, who said the no PVC option. Yeah. And Simon, yeah, I think that we're at least have the old versions of the docs now, which I think it took a while to get there. But being able to essentially, when you select a version, to go to the right page in the old version is something that I think is still new. So that's something that I'll give some feedback to the docs team. Version with current page. I have my notebook here where I take notes. And I think, the dream feature there would be show me the actual diffs between these two things. It'd be awesome if you could actually go and maybe redirect to GitHub or something like that so that you could actually see what changed on that particular page. Now there's still bigger, it becomes problematic when you have what we'll find is hey, this page is getting big. Let's break it into a bunch of smaller pages. Well, then how do you actually redirect across versions for that? But we should at least be able to do something there. Okay, so let's go ahead. So we Kubeless function deploy, get Python, this thing, and it's going to be an HTTP trigger. Okay, and so let's dissect this. This is the name of the function. So we're naming the function get Python. So there's already a little bit of a difference from Amazon because Amazon, they don't let you name anything. Everything is you submit it and then you actually get an opaque ID back. But here we get to name the thing. The runtime, it's the Python 2.7 runtime. If you talk to anybody in the Python world, they're going to be angry that's not Python 3. We're loading the function from a file, so test.py. That implies that you can actually load it from the command line too, which is kind of funky. Yeah, and then having the doc search scoped to the version. Yeah, okay. I'll add that also. There's probably issues somewhere in the doc repo around that, but I'll at least see if we can find those. And then handler, test.foobar. This specifies the file and the exposed function. Okay, so this is what function you're actually going to call inside of that file. And then this says it's going to trigger via HTTP. That sounds usable. Let's do that. Boom. Okay. And now if we do get functions, there we go. We have that. And one of the interesting things here is that this thing, let's see. So let's see what this thing looks like. So we have some deps. We actually have the function right there. And so that's kind of fascinating that the actual text of your program is sitting in the CRD. That makes sense. There's a maximum size to a resource, to a CRD, and or at least I know there's a maximum size for a config map in Kubernetes, which is about 1 megabyte. And I would assume that same size actually applies to CRDs. And so if your function that you're trying to activate here ends up getting bigger than 1 megabyte, you're going to have a bad time. But I would imagine that's pretty rare. And then we have runtimes. It's an etcd limitation, yeah. Well, etcd is an implementation detail, Andy. We could obviously split it up across multiple etcd keys. I'm just trolling Andy here. All right, and so there's Python. Then there's things like scheduling. And then, oh, this is interesting. There's the template here. And I wonder what this template is for. This is for is this like a deployment template or something? I don't know. That's interesting. Then there's topics, which I assume is for the pub sub stuff. And this says that it's an HTTP type. So there's a little bit of union-y stuff going on here where it's this is HTTP. I assume that if this was cron, then you start looking at schedule. If this was the pub sub type of trigger, then you start looking at topic. One of the interesting things here, this is looking at this here, and maybe this is just me being dumb about serverless. Are there situations where you'd want to have the same function triggered from cron and from a topic and from HTTP? And I definitely could see it maybe it's triggered from a topic, but then you also want to, when you're doing testing, you may want to hit it directly with HTTP, or if something got dropped or you want to inject it, you might want to do that. But I guess you could do HTTP and then you could have a function that goes ahead and listens on the pub sub topic and then calls the HTTP one. So maybe that would be the right serverless way to do this stuff. So that's interesting. Okay, so that sounds great. And so the other types of triggers, so you can do schedule or the topic stuff. We can get the functions. Oh, but then you can also do Kubeless function ls. And that shows you this here. All right, so this is something that I think is fascinating. This is a little bit of a digression. Kubeless is noun, verb, function, list. Kubernetes is verb, noun, get functions. And if you look at other command line tools, like if you look at like gcloud, compute, get, instances, get would be the gcloud command. And I think AWS actually works the same way, where you essentially name the thing and then the verb that you want to do on that. And so it's interesting that Kubeless chose the noun verb method for this, which actually is a little bit different from kube control. When we were doing the command line client for Arc, and that's the stuff that Andy here works on, we picked doing noun verb, right? So it's like backup, schedule, get. I don't know. I'm probably screwing it up, but and one of the feedback that we heard was a lot of people are like, "Oh, that seems so weird when I'm used to Kubernetes where it's verb noun." And I think the reason why it works okay for Kubernetes is that there's a set of operations that are common and relatively generic across all the different types in Kubernetes. But you start seeing it get a little bit weird when when you look at the code for how this stuff works, it's a little bit fractured, because if you do like kube control create help, there's like, oh, there's all these things that you can create, cluster roles, quotas, secrets, right? So it's kube control create secret, but that's like custom code for secret, because it has a whole bunch of stuff that's very specific there. Whereas I could see, kube control secret create would make sense, and you could have list, you can, update and set and stuff like that. So that's kind of fascinating. And then one of the things we're doing with Arc is we're adding aliases. This is what Andy's saying, for doing the verb noun thing, just so that if that's what people's fingers are used to, they can do that. Okay, so that's a little bit of a digression, but Kubeless is noun verb. Okay, so we have function ls, which is similar, but it does interesting things like it pulls out like the namespace and the handlers and stuff like that out of that. Okay, and so Daniel says the idea is to make it CLI compatible with Google Functions. Okay, yeah, and so Google Functions, I assume, uses the gcloud tool set, which is noun verb. Yeah, so it's RPN versus PN, right? Like, type of thing, right? People go to war over these things. So one of the interesting things is that they have this like kubeless function ls, and then they have specific columns here. And so that's really nice because it knows about those columns. One of those things, if you look at the roadmap around CRDs, is to be able to have more metadata about CRDs that things like kube control can use to actually say, hey, for this particular CRD, here's the different columns that matter, and here's the ways to format them. And there's actually work to move some of that formatting from being client side to server side. And so that way, at some point, kube control get functions may be able to, by default, actually give you sort of more information that makes sense for them. So cool. Okay, so we got that. And then let's call the darn thing. So we can call it, okay. So echo. Okay, so we can call it. Boom, boom. Okay, so that's connecting to the function. So I'm connecting to something. And then I assume I'm doing like a post, since I'm sending data. And that data gets parsed and echoed back to me as JSON. So that's pretty cool. And then and then I can do a proxy. I already have my proxy running. It's running at 8,000. So I can curl data, another echo, and I'm going to, okay, so proxy, I'm not a fan of proxy for stuff like this, because proxy ends up doing a whole bunch of munging of stuff. It actually does things like looks for like, references to other resources and writes them, because it ends up nesting these things on a sort of nested path and stuff like that. Jose says, do you guys plan to bring side projects like Kubeless to the main project? Thought about the same when describing Arc and Sonobuoy to some colleagues. Okay, so this is a deep topic and I'm going to get to that, but let me go ahead and let me make this work. Okay, that didn't work because I'm talking to 8080, but my thing's hosted on localhost 8001. Oh no. Proxy namespace services, no endpoints. Get services. Get Python. Oh, okay, wait. It's looking for interesting. It's looking for 8080. It probably doesn't know to map it to 8080. It's probably trying to talk to port 80 there. That's interesting. Or services get Python. Let me see this real quick just to see if I can figure that out. It's called function port, and I think the proxy probably doesn't know to talk to function port. So I add 8080. Yeah, so I want to look at Fission also. So yeah, so I'm looking at Kubeless now. I want to look at Fission. There's also this other one called OpenFaz, and there's function with a K, but I think that one, I'm not sure how much is going on there. Okay, so if I do this, services, where do I add it? Juan Joe, do you think? Yeah, that's right. Okay, that's what I would assume is get Python : 8080. That'll actually do it. Boom. Yeah, that's what I would expect there. Because I'm saying this is the service that I'm doing it. But I could probably go through and you could do a port forward to the endpoint of that thing. I really want to have port forward to a service. That's my thing that I want at some point. Okay, so Jose, you were asking about sort of like what about bringing these things into the main project? And this is one of those things that the newly elected steering committee for Kubernetes is going to be thinking about very carefully. And it comes down to, do we want to have everything that's in the Kubernetes ecosystem be part of the Kubernetes project, right? And do we want to have a world where folks feel like they have to be part of Kubernetes for them to be part of the community and for folks to know about them? Or do we want to actually say, hey, you know, let's keep Kubernetes very focused and then have lots of room for people to be able to do other things and have a big ecosystem on top of it, right? And if you think about Kubernetes, and I like to as sort of like a little bit similar to the Linux kernel, right? The Linux kernel is one Git repo. It has its own processes, its own way, its own community. There are good things and bad things about that community, right? But there's so much value built on top of that. And by not trying to actually, and one of the things that, for good or ill, the kernel community inside, for Linux has gotten right, is that they have a very clear line, right? The stuff that's in kernel mode is part of the kernel, and the stuff that is out of kernel mode is not their problem. It's a little bit of an oversimplification, but because you have that clean line, now what you have is you have people taking the Linux kernel and you have them using it on Android phones, right? And the user mode parts on Android phones look very different than when you take, that same code base, you compile it with different options, and now you're using an IBM mainframe, right? Very different options between those things. And so if we want Kubernetes to be able to have the flexibility to work across time and across of lots and lots of different environments, not picking winners, not actually tightly coupling to things that can cleanly be built on top of Kubernetes may be the right move, moving forward. Now, that being said, there's also a lot of projects that are open source and they want support from something like Kubernetes or the CNCF in terms of the community, the processes, the testing, the IP protection and stuff like that. And so there's definitely trade-offs between those things. And those are some of those things that the Kubernetes community is wrestling with right now. And so that applies to things that are outside, like Kubeless and Arc and Sonobuoy. I don't want to speak for the Kubeless folks. I don't know what their plans are eventually for this. But I think it also applies to things that are already in the Kubernetes project, like Helm, right? I mean, Helm is great. Everybody loves Helm, but Helm is is a clean sort of layer on top of the rest of Kubernetes. It really is not at the same level as the kernel. But yet it's obviously part of the ecosystem. So that's something that we're really struggling with right now. Yeah, so still in the early days there. Okay, so cool. That's a little bit of a digression there. And then XYZ says there's also this function project, FN. So I'll take a note on that. FN project. All right, so the next thing I want to do, we're running out of time here, so there's a bunch of stuff going on here. We got the pub sub stuff, and this obviously starts bringing in Kafka, which is interesting. There's the cron stuff that there's no examples here, but there is that capability, so that's pretty cool too. You can create pub sub topics, Kubeless. We have auto scale. So, okay, how do we auto scale? Function, ingress, topics, and version. I want to play with the ingress stuff. I want to see how that works. One of the things that I'm wondering about, and I'd love to dig in, and I don't think we're going to have time, is if we looked at that function there, the CRD definition here, and we have the runtime Python 2.7, and I'm really interested how much customizability is there around introducing your own runtimes. So that's something that I'd love to dig in at some point and really understand what's going on there and peek under the covers. Because I think one of the things that let's say, I could imagine, and this is one of those advantages that running your own infrastructure might have over something like Lambda, is I could imagine that I'm running my Kubernetes cluster. I have a set of nodes that have GPUs, and I want to find a way to actually maybe have a runtime that has support for claiming the GPU, right? And so I'm serverless in that case. Maybe it makes sense to do this, maybe it doesn't, I don't know, I'm just spitballing here. You'd want to actually get a little bit more creative there about scheduling, because maybe, you have to assign the GPU also, and so there's some scheduling constraints when you're actually spinning up the pods to back these things. You would want to constrain it to only the nodes that have GPUs and not the other nodes, and so that's another scheduling thing. And then you'd probably want to build your own sort of runtime environment that would be say Python plus TensorFlow plus GPU support, because it turns out that whenever you're using GPUs, the libraries that you're using to access those GPUs end up being pretty version locked to the kernel that you're using and the hardware platform that you're running on. And so I'd really be interested to see what does it take to actually do a custom runtime here. And I was hoping that it'd be cool if there was if there was another CRD for runtimes and you could actually manage runtimes using CRDs like everything else. But I'm not seeing that here, so that's interesting too. But let's play with ingresses and let's see, because I have ingress set up, and let's see if we can get that working, or if I'm gonna hit another. So it says hit this doc for that. So let's see if we can get ingress working. All right, so here we have our hello get.foo. Okay, close enough. We already got that. And we get the pod and the service. So we actually have kube control. So this thing went ahead and it created a service for us. Now we have a get Python service. So this is actually really interesting. This is one of the things I like about Kubeless, is that it creates a thing that's just it can integrate with the rest of your Kubernetes world, right? So Kubernetes is all about services and stuff, and this thing creates services. And so that means that stuff that you're running in Kubeless can really stitch together with everything else versus sort of being a complete layer that actually sits on top of it. So that's actually really cool. Now, when we define the function, I wonder why I picked port 8080. That's an interesting thing. I'd want to dig into that too. And then create route. So Kubeless ingress will actually do this for you. So let's do. Okay, so in this we'll do. How did it pick the host name for that? Okay, you can set the host name. Okay. So Daniel says, agree, it's still early day. Okay, no, people have contributed custom runtimes. Microsoft has a .NET one, but it's not straightforward yet. So, okay. Yeah, .NET's another great example. With .NET Core, there's a lot of room to really, bind that in here, and that's obviously changing. And, at some point somebody's be like, where's the Erlang runtime? And I don't know, Erlang's always my go-to example. Where's the Haskell runtime, right? Those people. Where's the Rust runtime? Okay, so we have this thing here. Let's go ahead and do that. And these guys, so I do Kubeless, ingress, create, route. So you got to name the routes. Function, you name the function is get Python. and then host name equals kubeless.backsplice.io. So I set that up earlier. And so this will create the ingress. Okay, so this is kind of cool. So like this is just a nice little shortcut for setting this stuff up. You could probably create the ingress yourself, but k get ingress or k create does not have an ingress thing here. So it turns out that like right now, if you're using plain old Kubernetes kube control, creating ingresses means that you have to go ahead and create YAML files, right? And so that's kind of a pain, and that doesn't fit with the aesthetic here. And so Kubeless helps you do that. This is, I think, an example where if it were easier for folks to contribute to kube control, and if we made it more generic, that capability of sort of a one-line command to create an ingress would be something that it'll probably be built into kube control instead of having Kubeless be able to go ahead and do that. Because I don't think Kubeless really did anything fancy there. So let's go ahead and look at this. Yeah, I mean, it didn't really do anything fancy here. It just went ahead and set up the rules correctly for you. But now, okay, so I'm stalling here because I'm afraid to try it. Okay, let's do kubeless.backsplice.io. Well, that sucks. All right, I think I'm hitting something. I just set this up before we started this. That's hitting my ELB just fine. That's actually probably making it to my Nginx ingress controller. I'm getting a 500 there, which is interesting. It's not clear who's actually returning the 500. Is anybody actually telling me this? Actually, what is I always forget the keyboard combo for this. Window, no, it's view developer tools. So this is, you can watch me try and figure out how to debug this stuff. So I look at network, I do this, it's getting back a 500, the response headers says it's Nginx that's actually returning the 500. So Nginx is not happy. I'm not going to debug that right now because we're running low on time. I probably screwed something up when I was actually getting the Nginx ingress control. I didn't test it before we went ahead and started this. But you can watch the Nginx episode and actually watch it work, make sure it's working. Well, maybe it's post with data, not get. That's a good point. Let's change our function. Let's try one more thing here. Is it may be a 500. I wonder if the 500 is coming from Nginx or if the 500 is coming from my function. So let's just do print. So what is the return versus? I don't know what it means when we return the function here, but let's do print hello. And I don't know what the return does. Let's see if that works. Oh, and I have to. So function. So it already exists. So Kubeless, how do I do an update? Let's see. Oh, I have an update instead of deploy. And it's probably going to complain. Oh, okay, that seemed to work. Default backend. Okay, so that means that the service is not up yet. Oh, and we're still getting the 500. Okay, so the 500 is coming from the thing, and it's expecting a post. Let's see if we can figure this out real quick. So you know my URL. So yeah, you tried it with curl with post and it worked, Daniel. So yeah, but you should be able to actually do a get on this. So let's actually like return hello world. I want to make that work. Let's figure that out. Oh, there's implementing a new runtime. That's cool. Developer's guide debugging, that's not it. Usages, runtimes, ingress, running on ACS. Trigger, okay, so you can pass environment variables. There's a runtime. You can have dependencies that are specific to the runtime, I'm sure. Trigger HTTP. For Python, we use bot, and we also add routes for health checking and monitoring, event trigger, custom runtimes. This could be my like Python rustiness here. But this thing, oh, so you return. So here, oh, let's try route. Will that do it? I don't know. The Python function used the context argument. Drop the argument and it might change it to a get. Okay, good point. Let's try that. Oh, you're saying this thing confused it. Okay, so we'll just do hello there. And we want it to be bold because we are bold people. Update. And then it takes it a second to actually sort of make itself live because I assume it's spinning pods. So we're seeing the default backend because it took the old one down. So this is an interesting thing. So like I think, feedback on Kubeless is that I should be able to update a new version without getting 400s. All right, so now I'm getting a 200, and this thing is, we're getting text HTML, and then the response, no response data. Okay, it must be that I'm printing it. I want to return it. Okay. So the interesting thing is that I think you definitely get a feel for like you can debug and deploy and debug and deploy, and that stuff is actually pretty cool. You can kube control log. So yeah, it's just a pod. So you can go ahead and read that, right? So the interesting thing here is it looks like when you do an update, oh, look at that, hello. We got a bold hello. Boom. Oh, here, I'm going to make it really big. Oh, wait, no, not that big. That's the wrong thing that's getting big. Huh. View. Oh, that's hilarious. I like zoomed in on my developer tools, and now it's confused and I can't actually zoom back out on my developer tools. Now if I do, oh, they're still big. Oh, my developer tools are big. Is there a way to actually, okay, I'm gonna have to figure that out. Settings. Oh, they're huge. Oh, that's funny. I accidentally zoomed the wrong thing. I'm gonna probably have to restart Chrome. All right, so we got a big hello there. That's awesome. And yeah, and so so let's look at one more thing, and then I'm going to sign off here. If I look at pods here, I can see this thing is just a pod like everything else, and it's using deployments to actually roll this stuff over. And it's like, what is the life cycle of a function pod? How long is it running? I don't know. That's a good question. I mean, maybe. I assume it's just it runs as long as it needs to run. There was a hint here. Oh, that's the wrong thing. Where are we at? There was a hint here around when I did Kubeless. There was an autoscale, manage the autoscale of functions. So it may plug into the horizontal pod autoscaling to actually scale things up and down. In that case, the life cycle of a function pod would actually depend on scaling up and down. We can see we have the pod there, deployment, so it's doing replica sets. Now when I do a Kubeless function and I can do autoscale, call, delete, deploy, describe, list, logs. Okay, so I can do all that, update. Let's do, and I can do this thing. Oh, what did I call it again? It was called get Python. And I'm going to do schedule, trigger, topic, and memory, namespace. Okay, oh no, okay, so how do I, Kubeless, auto, let's play with scale. Based on monitored metrics. Delete an autoscale from Kubeless. I don't know if I have the right metrics. Maximum number of replicas, minimum number of replicas, value of the average metric across all replicas. If metric is CPU, QPS. Okay, so you can do it based on QPS. Yeah, so this is, I think, this is one of those things that, the folks are talking about here that I think is a difference between the philosophy of Kubeless and some of the other mechanisms out here, is that Kubeless maps a function to a pod, and it essentially manages pods without needing to actually build to build Docker images, to deploy those, to manage that. So in some ways, it's like a very much a sort of curated way to actually build and run deployments. And so it fits really well with the rest of Kubernetes, but it may not be quite as lightweight as some other systems that are much more focused on 0 to 1 scaling. And it looks like this uses horizontal pod auto scaling, which is great. But one of the things that I think would be interesting here is other metrics for scaling. It turns out that scaling based on CPU and QPS, both of those things can actually be problems sometimes. And so being able to have some more manual control over scaling is something that I think would be awesome. Okay, so let's see. And then Super Stanis Lovas says, "Oh, you are awesome. Thank you. It's just my beard. So fun to look how I fix things. Yeah, I get myself in trouble and we figure out a way to get it out. Where should I start to learn this stuff? I would say, oh man, this is such a big topic. I would say find the problem that you want to solve and then solve it badly and then solve it better. And what you're going to find is that the first time you start programming, you start doing this stuff, you know, it's a lot of work. You're copying and pasting stuff, but you're learning along the way. And then you'll be like, you'll look back on the code that you wrote 6 months ago and you'll be like, oh my God, that's awful. Or the systems that you deployed last, 6 months ago, and you're like, that's horrible, right? But over time, you end up getting better at it. There was this thing on Hacker News the other day, and it's probably still up there. It was actually yesterday. Hi, CM from Ireland. There was this thing where this person looked at some of his code that he had written before where he tried to rewrite the Terraria game. And he's like, it's the worst code he's ever seen. And it's like, it's a badge of honor how bad it was. So, in terms of how do you get started, you get started by getting started, and you get started by motivating yourself by solving a problem that you want to solve. So, I'll give you an example. What I would love to do is to build an automatic provisioning Minecraft system on top of Kubernetes where you had a dashboard that you could go to, it hit a button and it would launch a Kubernetes pod, and you could, get the console stuff back. And then when you shut down your game, it would do a clean shutdown, take that data, maybe save the data off to S3 so that you're not actually, paying the cost of EBS all the time. And then, maybe do some sort of special ingressy types of things to be able to redirect. I think that would be a fun system to build on top of Kubernetes. And so if you're looking for a project, do that and do it badly to begin with and then get better over time. So, so hopefully that was fun. We went, I find myself always doing about an hour and a half on this stuff because I probably talked too much at the beginning. But hopefully everybody learned some stuff, and not sure what I'm going to be doing next week. Maybe we'll dig more into Kubeless and I'll actually learn something, or maybe we'll pick up one of the other serverless systems and start taking a look at that also. So thank you again, and I'm signing off. And if you enjoy this, let other folks know. Hit the subscribe button and thumbs up, and spread the word. And I'll keep doing these things. And I'll talk to you all later.